today we're going to be talking about how we can factor polynomials in different ways. Okay, which the first technique we're going to talk about is the GCF, or factoring by the greatest common factor. Now, factoring is the reverse of distributing. So essentially what factoring is you're going to be dividing by common values into each term. Okay, so distributing means to multiply, so factoring is a form of polynomial division. So it's the reverse of distributing. So after you factor, if you actually distribute your expression back out, you'll actually end up with what you started with. So they kind of go hand in hand. So let's get going on the GCF. So the GCF is called the greatest common factor. So when you factor using the greatest common factor, you're looking for the largest number that will divide evenly into each term. Okay, so let's just talk about just a general idea of what factoring is. So if I asked you, what are the factors of 6? What do you guys think are the factors of 6? Holy hot dog, you guys are so smart. Okay, the factors of 6 are numbers that actually multiply to equal 6 or numbers that will divide evenly into 6. So you can kind of think of it either way. So the numbers that divide evenly into 6 are 1, 6, 2, and 3, which you guys already told me because you're geniuses. Okay, so using that information, we're going to be thinking about the largest of the numbers that will divide into every single term to get our greatest common factor, and then to factor using this technique. Okay, so first we're just going to practice identifying the GCF, and then later on we're going to actually factor using the GCF. So let's just talk about how we find the GCF. So this is example 1 right here, so go ahead and start copying this down in your handy dandy notebook. So example 1, when you are identifying the GCF, what I like to do is I start by identifying the coefficients, or the numbers, in front of the x. Okay, so the numbers in front of the x, or just the numbers in general, are the 8 and the -4 technically. But I want to know, what is the largest number that divides into 8 and 4? It would be 4. So if I'm just looking at my numbers, the largest number that divides into 8 and 4 is 4. Now, if you are going to include a variable in your greatest common factor, you must have variables in every single term, which if you guys see here, I only have a variable in my very first term. I don't have an x in this term, so this is not a common factor. X will only divide into my first term, not the second term, because my second term doesn't have an x. Okay, so I cannot include x in the GCF. So my GCF for example 1 is simply 4. All right, example 2. Again, I look at the coefficients first, so you want to ask yourself, what is the largest number that divides into 15 and 45? You guys are too cool for school. It is 15. So the largest number that will divide into 15 and 45 is 15. And now, after that, I look at the x's, which if you guys see this time, holy hot dog, I do have x's in both terms. Look at that. And don't forget, if you ever have an x without an exponent, secretly there's a 1 in the exponent. So watch it. Okay, so I want to know the greatest common factor is the largest number or variable that you can divide into every single term. So if this first term has 1x, and this second term has 2 x's, if I'm trying to grab the same number of x's from each term, what is the largest number of x's I can grab from each term if the first one has 1x and the second one has 2 x's? Well, you can't grab 2 x's because the first term only has 1x. So the largest amount of x's that I can grab from both terms, if I want to grab the same number of x's, would be 1x. So the GCF would be 15x. Technically, x to the first power. Okay, so a shortcut when you're finding the GCF, if you have variables, the shortcut is to pick the variable with the smallest exponent, smallest. Okay, so x to the first was the smaller exponent, so that is the one I included in my GCF. So that's the shortcut. Shortcuts are fun, right? All right, now example 3. Let's look at those pretty coefficients. Look at those bad boys. Beautiful, right? Okay, so I'm going to ask you guys, what is the largest number that will divide into 6, 12, and 21? Like normal, you guys are always right. It would be 3. Okay, and then I'm going to look at my x's, which if you guys see, if I'm going to include an x in my GCF, I must have x's in every single term, which if you guys see here, I only have x's in my first 2 terms. So I can't have a GCF that contains x because x will not divide into my last term. It doesn't have an x. Okay, so if you have an x in your GCF, you must have x's in every single term, so just be careful. So my GCF for this one is simply just 3. Okay, and example 4. I'm going to look at my coefficients again. So the largest number that will divide into 11 and 7, well, there isn't really anything other than 1 that will divide into 11 and 7. So guess what? The GCF is 1. Don't overthink it. Okay, and then if you see here, I only have an x in one of my terms. Okay, so that means I can't include x in my GCF. So this GCF is only 1. So there you go. In the next example problems, we're going to be actually factoring the polynomial using our greatest common factor. So we're going to take these problems one step past these. So get pumped up for the next couple of examples.